This 200-ton jet belonging to the Cathay Pacific had an emergency over the South China Sea. The pilots lost both engines in a very unlikely event. If they could not restart the engines, they had no choice but to land in the South China Sea. The story of Flight 780, which experienced an emergency at an altitude of thousands of meters, is based on official accident reports and eyewitness accounts. April 13, 2010. Juanda Airport is one of the top 3 busiest airports in Indonesia. The pilots of the A330 plane belonging to the flag carrier of Hong Kong aligned the plane at the runway for Hong Kong. They got clearance from the tower and powered up both engines of the plane for the 4.5-hour journey. The takeoff run was uneventful. At 8:24, when they were up to takeoff speed, they cut the wheels at the airport's runway 28. They began their climb to their cruising altitude of 38,000 feet. It was a beautiful morning for the flight. The sky was clear and the air was slightly windy. The aircraft they were operating was an 11-year-old Airbus A330-300 with tail number Bravo Hotel Lima Lima. It was a wide-body aircraft equipped with 2 Rolls-Royce Trent 700 engines. The aircraft was also equipped with advanced technologies and computers, which greatly reduced the workload of the pilots. There were 2 Australian pilots in the cockpit. Captain Malcolm Waters was in the captain's seat. He was one of the pilots in the company who became captain at a young age. Pilot David Hayhoe, a former Air Force jet pilot, was in the co-pilot seat. 309 passengers and 13 flight attendants would perform the flight. 2 of the 13 flight attendants were pilots, and 11 cabin officers. 322 people in total would make the flight. Let's take a quick break. We've put a lot of effort into this video, so if you find it informative, please remember to subscribe and like. Your support allows us to create more content for you. During the climb, the pilots observed slight fluctuations in engine performance. Engine number 1 was showing different readings from time to time compared to engine number 2. There were also fluctuations in the indicators, but such minor fluctuations did not initially pose a major problem. The pilots climbed to their cruising altitude of 39,000 feet. Only 25 minutes after takeoff, the ECM system, which we can call the brain of the aircraft, began to warn the pilots of a system failure for engine number 2. After receiving this warning after fluctuations in the engine indicators during the climb, the pilots decided to contact an engineer on the ground. After looking at the situation with the engineer, they observed that the other parameters of the aircraft were normal, and concluded that it would be better to continue the flight. In the following stages of the flight, the same warning continued to appear. The system also warned the pilots to avoid sudden power changes. They flew for 2.30 hours in this way. The flight engineer said that they had observed this in engine number 2 before and that the fuel-related part would be replaced after landing. All other engine indicators were still showing everything normal. Another hour passed. The crew was nearing the end of their 4.5-hour journey. They would complete their landing in just 30 minutes. The captain announced to the passengers that the air temperature was 29 degrees and the sky was partly cloudy and thanked the passengers for choosing Cathay Pacific. The pilots had traveled more than 3,000 miles from Surabaya to Hong Kong. They were about 250 miles southeast of Hong Kong Airport when the controller cleared to descend to an altitude of 23,000 feet. The pilots gave the descent command to the aircraft, left their cruise altitude, and continued their descent. Although the system showed a malfunction, the other indicators were normal and did not show any problem. While the descent was going smoothly, suddenly a small bump was heard and shaking started. The flight computer showed that the right engine had stopped. The pilots could not understand what had happened. The engine's indicators were normal. The captain pulled the throttle lever back to prevent damage to the engine and idled the engine. When the right throttle lever was pulled back, the noise and shaking from the engine stopped. The pilots did not lose their composure. They had practiced landing with one engine several times in the simulator. They contacted the tower and gave a pan-pan report, saying that they had lost engine number 2 and requested landing priority. They then requested the shortest route for landing. In the meantime, the passengers were completely unaware of what was happening in the cockpit. The captain pilot called the cabin crew on the phone. This was a situation that the flight purser was not used to during the landing phase. He understood that there was something strange. The captain pilot asked him to check the engine from the cabin window that the number 2 engine had stopped and whether there was any abnormality. The purser checked the engine without revealing the situation to the passengers and told the pilot that there was no fire or smoke in the engine. They were 185 kilometers from the airport, about 22 minutes away. The pilots had to rely on their only remaining engine. The captain called out to his co-pilot that he would make the landing, while the pilots were descending with their single engine as they should. At 8,000 feet, the captain pilot's fears came true. Engine number 1, the only engine running on the flight computer, had also failed for the same reason. This was the last thing they wanted to see. This engine was making the same noises as the other engine. There was no way they could make it to the runway unless they managed to restart the engine. Their descent rate was increasing. The aircraft system asked the pilots to idle the left engine as well. The captain pulled the power back on this engine as well. Without thrust, they would end up in the South China Sea. They were 96 kilometers from the nearest land. The plane was descending at 400 meters per minute. They were 5 or 6 minutes away from falling into the sea. The captain and co-pilot were in momentary shock. The captain tried to turn the power back on to both engines, but there was no movement on either engine indicator. The engines continued to idle. The co-pilot invited the captain to follow the water landing procedures. The captain responded in the affirmative. The co-pilot contacted the controller again, this time reporting a more serious situation, a mayday. All the planes on the frequency were paying attention to the plane in an emergency. The co-pilot reported that they had lost both engines over the South China Sea. The controller said they were clear to descend to 3,000 feet. In the meantime, the captain pilot took the plane under manual control. He aimed to better avoid the clouds and find a suitable position over the sea. Just a year before this emergency, the Sully incident, which we also told on this channel, had happened. The experienced captain pilot Sully Sullenberger had managed to land the plane in the river without a single loss of life, even though he had lost both engines. As a result of this incident, it was proved that it was possible to land on the water without loss of life. But instead of a calm river waiting for them, there was the Chinese Sea below them. Where the wave height could reach 1 to 2 meters, it was highly probable that the large engines of the wide-body aircraft would hit the water during landing and they would flip over and crash. The passengers on board were not aware that they had lost both engines. The pilots were rapidly descending towards the water. After unsuccessful attempts by the pilots to start the engines, the captain pilot had an idea, and he began to push the throttle lever of the number 1 engine forward very slowly. He pushed the throttle lever forward 1 millimeter each. Shockingly, they observed that the left engine power was slowly increasing. Engine performance increased from 20% to 30%. The captain pilot took the risk and continued to increase it slowly. They were trying to see if they could give full power to the engine, and the power of the number 1 engine had increased to 74%. They realized that the engine performance could not go above 74%. Fortunately, they had stopped the descent. 74% engine performance was enough to keep them in the air. The pilots took a deep breath. If they approached the airport with enough altitude, they would not have to land in the sea and would be able to reach the runway. The second engine was still idling. Since they were not sure how much longer the number 1 engine would be able to run, they climbed back up to 5,000 feet. They aimed to stay high. Even if both engines went out, they would at least be able to glide to the runway. They were 8 kilometers from the runway, and now they were at an altitude where they could reach the runway even if they pulled the throttle levers completely. But they had no chance to pass. The captain pilot had only one chance, and that was to land. The captain pilot pulled back the throttle lever of the intact engine, made a turn and aligned with the runway. He told the passengers and the cabin crew that they had an engine failure and that they had to be ready for landing. They put the flaps in position 1 and opened the landing gear. The controller contacted the pilots and told them that both parallel runways in Hong Kong were allocated to them for landing and that they could land on any of them. The pilots decided to land on runway 07 left. Within seconds, the flight computer warned of excessive speed. Their speed would not decrease. When they should have slowed down, their speed increased. The situation was once again out of the captain pilot's control. When the pilots looked at the gauges, they observed that although the throttle levers were the furthest back, the number 1 engine was running and its power did not drop from 74%. Even though the captain pulled the throttle lever, the power of the engine did not drop and remained stuck at 74%. They were facing this problem only 1.5 kilometers from the runway. They were flying at 444 kilometers per hour, 185 kilometers faster than they should have been. Now they were suffering from excessive speed. They had experienced 2 different emergencies on the same flight. The captain had no chance to pass and turn again to reduce the speed. The only solution was to try to land at high speed. The captain put the flaps in the number 2 position to lose speed. The length of the runway was 3,800 meters. The runway distance was quite long, but their speed was also quite high. They could not predict whether they would be able to land or not. It was inevitable that disaster would occur in case they left the runway. Low altitude warning started. The plane was going so fast that the flight computer didn't realize that the plane was in the landing phase. That's why it was giving these warnings. The wind was coming from 150 degrees at 13 knots. The captain focused on the runway with his nose down, and he wheeled hard on the runway. The wingtip scraped the runway on impact. The captain immediately gave the command to correct the plane. He had managed to regain control. He turned on the plane's reverse thrust. He was pressing the brakes on his feet to the fullest. The reverse thrust system of the right engine did not work. Only the left engine was working, so the possibility of veering off the runway was increasing. The plane was slowing down on one side. They were pressing the brakes so hard that the brakes were making a loud noise. The captain pilot thought they would not be able to keep up at first, but the plane managed to stop a short distance from the water. The pilots took a deep breath. They did not fully understand what they had just experienced. Now another problem was waiting for them. The brakes that stopped the plane weighing tons at high speed were overheating, and there was a risk of fire. When they looked at the indicators, they realized that the brakes had reached a temperature of 540 degrees, and it was obvious that there would be a fire. The captain immediately made an announcement and called for evacuation 3 times, and passenger evacuation began. The crew and passengers managed to leave the plane with minor injuries. Smoke and steam were coming out of the plane. Emergency crews at the airport intervened immediately and prevented this emergency. The plane was only 300 meters from leaving the runway. After the incident, the Hong Kong's Civil Aviation Department launched an investigation into the incident. The engine manufacturer Rolls-Royce sent engineers to find out what caused the problem. They had used this model engine in many aircraft. Was there an engineering error in the engines? In such a case, the company should have taken precautions immediately. It was very strange that 2 of the engines stopped due to the same fault. The investigators removed the flight data recorder, one of the 2 black boxes on the plane. This device records many parameters such as the altitude of the plane before the incident, engine performance, and fuel flow, thus providing information to investigators. The researchers noticed something strange in the data. When the pilots opened the throttle levers, the fuel flow remained constant, but the 2 engines did not react. There was a problem with the main metering valve that provided fuel flow to the plane's engines. We can think of the main metering valve as a piston moving inside a cylinder tube. This part allows the pilot to increase or decrease the fuel flow to the engine by moving the throttle levers. When they examined the valve with an electron microscope, they found a thin material on the wall of the valve. This thin material had caused the valve to clog. When they examined other parts of the plane, they found the same chemical substance in more than one place. So what was the absorbent polymer substance they found, and where did it come from? First, let's talk about how fuel is transferred to the plane. Fuel tankers discharge the fuel they receive from underground fuel tanks to the aircraft after filling the vehicle with the help of a filter. There are layers of filters in these pipes to filter out any possible different substances in the fuel. If water is mixed in the fuel, this chemical powder in the filter absorbs the water. As a result of the absorption of water, a gel-like substance is formed. This substance in the filter should have been in the filter, but in this case, the water-absorbing substance was mixed into the fuel. When they examined the fuel, they found another finding that surprised the researchers again. They found salt crystals in the fuel. The underground fuel tanks had been replaced just days before. The fuel tanks, which were located close to the sea, had not been cleaned properly, and seawater had mixed into them. As the fuel mixed with seawater passed through the tanks, the chemical filter in the pipes tried to hold the water, but after a while it caused the fuel discharge pipes to deteriorate. 24.5 tons of fuel had been loaded onto the plane before it left the gate. When the fuel mixed with the chemical went to the engines, it caused the fuel valve to jam and prevented the flow of fuel to the engines. The reason why the engine power was restored after the captain slowly lowered the number 1 engine was that this chemical substance had a soft, sticky structure. The chemical did not fully compress the fuel valve and was able to provide fuel flow to the engines as a result of the slow movement of the throttle lever. In short, the captain's last move of slowly opening the throttle lever saved the lives of hundreds of people. The incident was not a situation in that the pilots had previously trained in the simulator. so after the incident, the pilots were awarded the Polaris Award, one of the most important awards in aviation. After the incident, the company that produced the fuel pipes redesigned. More precautions and regulations were introduced for refueling aircraft. As for what happened to the 11-year-old plane, which was maintained and repaired again, continued to serve under the roof of the same company days later.